In this lesson, we're going to be looking at exponential equations. Our objectives: understand parts of an exponential equation, understand what an exponential equation looks like. Vocabulary: exponential equation. Equation in the form y equals a times b to the power of x. Growth: an exponential equation where b is bigger than 1. Decay: exponential equation where b is smaller than 1. First thing we want to look at in this is just the basics of an exponential equation. This a right here is known as our start. So just like in a linear equation, we have to have some place to start from. This is our starting value. This b right here is known as the constant multiplier. Now, if this constant multiplier is bigger than 1, that means that we're going to grow. We're going to get bigger as we go. If this constant multiplier is smaller than 1, that means that we're going to decay. We're going to get smaller from term to term. This constant multiplier is found by taking our new y value divided by the old y values, like we did in our previous investigation. So now what I want you to do is to see what an exponential growth and exponential decay looks like. So our best bet on this is to graph it and actually look at it. So what I've got is, this would be a growth because our b value, the part in here, so y equals a times b to the x. This b is in the parentheses because this is being multiplied here. Is bigger than 1. It's 1.5 here. So what we would do is we would take our x and put it in. 1.5 to the power of 0 would be 1. Power of 0 always gives us 1. So 2 times 1 gives us 2. So we have 0, 2. Then we have 1.5 to the power of 1, which is 1.5. 2 times 1.5 would be 3. Okay, this is where it starts to get tricky as we start squaring things and so on. So this one is going to be 1.5 to the power of 2. So we need to get a calculator out and take 1.5 times 1.5, or to the power of 2 if yours does that. So I get 2.25. Then I'm going to multiply that by 2. I'm going to get 4.5. Okay, and now I'm going to do the same thing with the power of 3. So I'm going to do 1.5 to the power of 3. Which I get 3.375. I'm going to multiply that by 2, and I get 6.75. So now we want to graph this and see what it looks like. So we start at 0, 2. We go 1, 3. We go 2, 4.5. And we go 3, 6.75. As you can see, there's kind of a slight, there's a curve here. It's not a straight line. Growth typically gives this type of look. It starts kind of low, starts growing as we go. Now we want to look at a decay problem. So here's a decay problem. Notice the a value is 8, so we're going to start at 8, and our b value is 0.5. 0.5 is less than 1, so this should make us decay. Well, 0.5 to the 0 power is 1, 8 times 1 is 8. So we're starting at 8. 0.5 to the first power would be 0.5. 0.5 times 8 is 4. Okay, now I'm going to need my calculator to do the rest here. So I've got to do 0.5 to the power of 2, or 0.5 times 0.5, which gives me 0.25. I'm going to multiply that by 8. I'm going to get 2. So I've got 8, 4, 2. Now I'm going to go 0.5 to the third power, which gives me 0.125. I'm going to multiply that by 8. I'm going to get 1. So now I'm going to graph that and see what a decay looks like. So it looks like this. So decay is basically the reverse of a growth. They look like the same, just mirror images of each other, if you think of it that way. So this has been Exponential Equations. If there's anything that you missed, make sure that you pause, rewind, and rewatch, and bring any questions to class. Thank you.